Thank you so much, Nikhil. So now as Nikhil has briefed you about the evolution of artificial intelligence, about vision, the training, so we can conclude that the present era of artificial intelligence is all about teaching or training the machine. So today we will mimic the vision into artificial intelligence. So we will build and train a deep net to create a binary classifier for mask detection. So let's first quickly run the project. So this project basically tells you whether or not you are wearing a mask. And as you know, in this COVID scenario, it can be very helpful for shops, malls, and etc. So as you can see, it is showing in the red box if you are not wearing a mask, and if you wear one, it will show you in the green color. So today we will make this particular project. And one more thing, if you observe carefully, it is showing a percentage at the top. Now, what is the percentage? So it also means that percentage is equally important in a particular project. So it also depends on project to project. Although, for example, it is okay to have 90-95% accuracy in project like these, but when it comes to project like self-driving car, we can't just let it go on the road with 90% accuracy, because in that case it will mean that it is killing 10 people out of every 100. We just don't want that. Anyways, so now as you have seen the project which we will build today, so the next question is how. And someone earlier in the chat wrote that it's too much of math. But the platform which we'll be using today, you don't need to remember any math. That is the beauty of that particular platform. So now, creating an AI project is like baking a cake. Now, how you bake a cake? There are several steps, which is collecting the ingredients, then mixing the ingredients in right proportion, then pouring the batter into the mold, which basically tells like how many layers or what will be the shape of the cake. And the next step is baking the cake in the oven. Then we have inspecting and checking that whether it is baked properly or not, and then decorating it, and at the most important step, which is tasting. So these steps we can follow to build any AI project. As you can see on the screen, on the left side, it is the steps of baking a cake. Then on the right side, it is steps of creating an AI project. It starts from loading libraries similar to collecting ingredients, and we go all the way down to testing our trained model of that particular project. So without any further delay, let's start building it. So this is the platform I was talking about. I will brief you about this platform at the end of this webinar. But for now, just let's start working on it. So what was the first step? First step was collecting the ingredients or collecting the libraries in AI project. So as you can see, we are dragging the libraries block like matplotlib, which will help us to plot some graphs. Then we have NumPy, which will basically help us in computation. And one more thing you might observe over here, that when you are dragging a block, the code automatically appears on the right side of the screen. So you don't need to remember code, you don't need to remember math. All you have to do is drag and drop, drag and drop. That's it. So now, what was the next step? The most important step is data set. As this particular project tells you that whether or not you are wearing a mask, so the data set also needs to be related to that only. So we have a data set with two classes, which is a binary classifier. Binary classifier. So as you can see, we have two folders, and in the first folder we have images of person wearing a mask, and in the second folder we have images person not wearing a mask. So we'll just feed in these images, tell our network, our model, our machine, just learn from it. Okay. So in the second step, we have seen the data set. We have loaded the data set by just the first block. And now one thing you might see, there is something called target image size. Now, why we are doing target image size? See, when baking a cake, you have to mix all the ingredients in the right proportion. You can't just add more sugar and sugar, then it will just ruin the cake. So similarly, when doing a project, you have to maintain a uniformity across the training of the project. So here we are just taking out the images, we are just converting them into a size of 224, 224 and 3, which is basically length, breadth, and the number of channels in the image, which you know as RGB images. So we have just done it over here. Now next, if you carefully see, there is something called data splitted into train and test. Now I will ask you guys that why we are splitting between train and test. So can anyone answer? I'm waiting on in the chat box. You can write in the chat box. So okay, so Varun has returned that so the train model can be tested. That's absolutely right, because the test data set contains all those images which our model hasn't seen yet. So in that way, it will tell us the how accurate our particular model is. So that's why we are splitting it in between train and test. And then we have a block where we are just shuffling the data set. So then now, what was the next step? Was pouring the batter into the mold, which basically decides number of layers on the cake we want. So similarly, here also we have to decide how many layers of architecture, how many neurons, as Nikhil has already explained you what neurons are, we require in our network. So here we have already created a 4-layer network, so which are basically we have two convolution layers, and then we have some dense layer. And you carefully see in between those, there is something called activation function. As Nikhil already told you about ReLU, and here also we are using ReLU. And the thing
to be to interrupt. So what Sachin, like he's talking about ReLU here, like the same thing to right wala पूछता. Now at every layer, you are there the input, the output which is coming, it is and the ReLU activation function is making it learn something. Certain information about the edge, certain intelligence which it will carry forward and then use it while it is doing a probability in the end. Go ahead.
Thank you, Nikhil, for the input. So each layer, as Nikhil has already explained, that it will it will extract some different features with the help of each and different neuron. So now, after we have created the layer, I want you guys to look at the last layer. Here we have only 2 neurons. Now, can anyone guess why we have 2 neurons? Anyone? 2 classes, right? So because it is a binary classifier and we have only 2 classes, whether a mask is there or not. That's why we have to enter 2 as neurons in the last layer, which is same as the number of classes. And at the last layer, we have to use sigmoid as our activation function, because it's basically used in cases of binary classification. Now that we have created the network architecture, we have loaded the data set, we have loaded the libraries. So what was the next step? Can anyone guess? If I just give you context, in cake it is baking the cake. So what can be the step next here?
Training.
So, yeah, training. Very good. So next step is training the model. So we are using these bunch of blocks over here, which will basically help us to select the loss function, which Nikhil was explaining. Like it will go forward in the network, then it will check how much loss it has caused for that particular epoch. Then it will go back again. So these blocks are basically helping us to select those loss functions we want, those optimizers or number of iteration, number of epochs we want to have in the architecture. So now here it is 2 epochs. Let's just change it to 10. So now we have completed almost all the steps. We have created the architecture, then the training is almost done. Now one step which is required, that we want to observe, we want to see, we want to visualize how our training went during the process. So for that, how we can achieve that? By plotting some graphs, obviously, because graphs are easy to interpret. So here, these bunch of blocks will help us to plot some graphs of accuracy and losses. Then we will get a confusion matrix also. And at last, we are just saving our train model. So that's it. This was the whole project of Mask It On. Now the next step is to train it. We have just connected all the blocks. Real training is still left. So
Sachin, yeah, before you train it, just spend one more minute and from for everyone can visualize and maybe go layer by layer just once.
Okay.
So first we loaded the libraries. This is good as well.
So can we go to the full screen mode at the right top? Yeah. Now it is clearly visible, and we can just also zoom it a bit. Yes. So let's go through from top to bottom. So at first we loaded few libraries, then we loaded our data set and did some pre-processing. Then we created the architecture with 4 layers, convolutions and some activation layers, dense layers. After the layers, what we had to do, we had to train it. So for that, we used this compile and fit block. And at last, we wanted to visualize how our training went. So that's why we are plotting some graphs. So that was the block code.